Hi, welcome to my channel, JaberTime. Today I'm going to go over rational expressions. We're going to do different types of examples, multiplying, adding, subtracting, and we're going to end up with simplifying complex rational expressions. So let's get into it. Rational expressions. Given a rational expression, we need to simplify it. We have two methods or two ideas. Factor the numerator and the denominator. Cancel any common factors. What do I mean by this? Let's take an example. Factor the numerator and the denominator. So we know how to factor. We just took this in previous videos. So we're going to factor this. That is x plus 4 to the second. You could double check. X to the second, 16, and twice AB will be 8x. Down here, it factors to x plus 4 times x plus 7. 11 comes from 4x and 7x. Multiply 7 times 4 is 28. Let me expand this so you could see what I mean. This has 2x plus 4 multiplied by itself this way. Cancel. As you see, cancel any common factors. And we can cancel the common factor because any expression divided by itself is equal to 1. That's one way to say it. So that's like 1. 5 over 5 is just 1. So that's how we simplify rational expressions. Question. Can the x squared term be cancelled? Sometimes students do. The answer is no. A factor is an expression that is multiplied by another expression. Alright? You have to be careful. Earlier, these are factors. You could cancel when it's factors. Alright? When it's addition in between terms, you cannot cancel. When you have factors, you could cancel common factors. Moving on. So the answer is no. X squared is not a factor of the numerator or the denominator. It's not a factor. Multiplying rational expressions. Here's an example. To multiply, we're going to factor the numerator and factor the denominator to the best that we can. This right here factors to x plus 5 times x minus 1. From here, I could take 3 out. I'm going to multiply the numerators and the denominators, which sometimes we call it multiply across. Make it one fraction bar. Okay, now that's what I have. Now we're going to cancel the common factors to simplify. Do you see any common factors? Do you see the x plus 5? Those are factors. There is no addition. Alright? When you cancel this with this, this is what you have left. And that should do it. So that is how you multiply. Let's see how we can divide. Dividing rational expressions. So here I'm highlighting that it's division, so you gotta be careful. We're gonna rewrite as multiplication, rewrite as the first rational expression, keep this the same, multiplied by the reciprocal of the second expression. So this becomes times, and this now right here, we flip them, we call it reciprocal. Now we go back to the multiplication like last example. We factor, we put them all in one fraction bar, and we cancel common factors. Factor the numerator and the denominator. This factors, they all factors. Difference between two squares, difference between two squares. X squared plus 2x plus 1 is x plus 1 times x plus 1. 2x to the second plus x minus 6 is 2x minus 3. That's a factor by grouping. And times x plus 2. multiply them, put them all in one fraction bar, and now look for a common factor. Now this time, because there is more than one, I'm showing you or highlighting the common factors, the x plus 1 and the x plus 2. Take them out, and this is what you have left. And that should do it for this problem. Now, adding and subtracting rational expressions. Adding and subtracting rational expressions works just like adding and subtracting numerical fractions. Like when you add 1/2 plus 1/3, you need a common denominator, which is 6. And then you go on from there. Same concept here, except it's expressions, it's not just numbers. To add fractions, we need to find the common denominator. The easiest common denominator is the least one, the least common denominator. That doesn't mean like you can't go higher, and it works, but nobody does. Why would you make it complicated if you could take the least one? So we have 5 over x plus 6 over y. What's the common denominator between x and y? As I mentioned earlier, let's take different numbers than 2 and 3. If this is 3 for x, and let's go 7 here. They don't share anything, 3 and 7. But 3 is a factor of 21 and 7 is a factor of 21. I could make both 21 by bringing the 7 next to the 3 and bringing the 3 next to the 7. This way they will both have the 3 and the 7, which is a product of 21. So the least common denominator is between x and y is x times y, just like my example 3 and 7. So here it's missing the y, we'll bring it. Here it's missing the x, we'll bring it. But how do you do it right? You multiply here top and bottom side by y. It's like multiplying by 1. You could call it games, you could call it skills, tricks. When we multiply by 1, you're not changing the value, you're changing the look of it. So 5 over 10, if you multiply by 2, top and bottom side, it becomes what? 10 over 20. Still the same value, still half. But we're changing the look because we want both fractions to have the same value, which is, in our case, xy. Multiplying by y over y here, or x over x here, does not change the value of the original expression. It does not. It is just like multiplying by 1. So when you do that, that simplifies to the following: 5y over xy and 6x over xy. Instead of writing yx, I just wrote xy to have them the same look, and usually we write AB, we don't write BA. Same concept. Now when we have a common denominator, all what you need to do is one fraction bar, copy the denominator and add the top ones. xy as a common denominator, 6x plus 5y, 6x plus 5y, or 5y plus 6x, either way is fine. And that should do it. Subtracting fractions will work the same way. Subtracting rational expressions. Here's an example. We're going to factor numerators, denominators to the best that we can. This is the difference between two squares. And this factor is 2x plus 2 to the second. Multiply each fraction to get the LCD. Well, this one is x plus 2 times x plus 2. So I have 2 of x plus 2. This one has 1x plus 2. It's missing the other one. It has to have 2. They both have to be the same. This one has x minus 2, but this denominator is missing it. And this is what you do. You just bring in what's missing here. You bring in what's missing here to make them identical. So here I'll bring the x minus 2. So if you look at this, I have 2 of these guys and 1 of these guys. And now I have 2 of those x plus 2 and 1 of the x minus 2. They're both the same denominator. Then we multiply. Make it one fraction, make it one fraction. LCD is available. Same thing, even though it's written the other way around, doesn't matter. 5 times 2 is the same thing as 2 times 5. Now we combine the two fractions because they do have the common denominator. We do that, and we end up the top part minus this part. Now we're not done here. We're not done. This is what you do. We're gonna apply the 6n and the minus 2n. It's called distributive property. Once you do that, sometimes more steps are needed. Minus 2x and 6x will give you 4x. Minus 12 and minus 4 will give you minus 16. And that should do it. Now, one more step. I said that should do it, but actually, look, noticing the 4x and minus 16, they both divide by 4. So 4 is a common factor. So we could take the 4 out as a common factor, and now that should do it. Sometimes I get excited so quick. That's my excuse. Let's move on. Alright, now we're gonna talk about simplifying complex rational expressions. That's like more than one fraction bar on top of each other. Nobody likes them. I don't mind. It's not like I don't like them. They're okay. How do you handle it? I'll show you step by step. Begin by combining the expressions in the numerator into one expression. This is my main numerator, and this is my denominator. This is my main fraction bar. So I'm using green to show you that this is what I'm looking at. So let's work on this one, and we'll come back to the problem. How do you add these? I need a common denominator, which is, look at this as y over 1. So between 1 and x, that should be x. So this one is missing the x. This has the x. We'll bring it in. We add them up. Now it's xy over x plus 1 over x becomes xy plus 1 over x. Now this is my new numerator as one package, one fraction, not like a sum of two things. We go back to the problem. Now the numerator is a single rational expression, and the denominator is a single rational expression. Single on top, that becomes on top. This is what I mean, single over single rational expression. Focus on this right here. This is my main division, not this one, not this one. We're gonna change the division to multiplication. First, I wrote it this way so you could see it clearly, step by step, as you could see. Change it to multiplication. If you do that, you have to flip this and take the reciprocal of x over y, which is y over x. Once you're done, multiply across, and that's how we do it. Nothing's gonna cancel, as you could see, and that should do it. Not too bad. Not too bad at all. So if I went too fast, go back to it. You could pause the screen anytime you want by hitting the space bar, as I always mention, and hitting the space bar again will play the video. So the space bar acts like pause and play. Thank you for watching, and I'll see you next one. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.